Today we have Christian Posta, Global Field CTO at Solo, and Joe Kelly, Tech Lead here at in engineering here at solo.io, who will be driving the webinar. We are going to do live Q&A, so but we'll handle those all at the end. So please enter them into the chat or Q&A window as we go, as you think of your questions, and then we'll handle all of those at the end. And with that, I'd like to hand it over to Christian.
Sure. You should be able to hear me. Like Betty said, we got Joe Kelly. Joe, do you want to do a quick intro for yourself?
Sure. Hi, everybody. I'm Joe Kelly. I'm an engineer at Solo, most recently working on Gloo Federation.
Yep. And so a lot of the stuff that we're going to show today, Joe and his team here on the engineering side have been hard at work at both getting it out, as well as the next set of features for the roadmap. So we'll go into those details. Again, I'm Christian Posta. I've been at Solo for almost 2 years now, and I came here because I'd been involved in the open source community for a while in service mesh land and previous generations of technology, Kubernetes and so forth. But I came to Solo because I really believed that just like Kubernetes and Docker changed the way we deploy applications and manage them at scale and in cloud-like environments, I believe that there was a lot of opportunity for solving the application communication challenges in a very similar way. Just like Docker kind of revolutionized how you package your applications, and Kubernetes, with Kubernetes you can start and stop and check on the health of your application and so forth, regardless of what's running in that container. I felt that there's a large opportunity for solving the application communication challenges in the same way, a application language and framework agnostic way. And hence, things like service mesh started to crop up. But the bigger challenge is in how do you operationalize these types of technologies, and how do you automate? How do you put the infrastructure in place so that you can automate on top of it? And so at Solo, what we're doing, so that's why I was excited to come to Solo, is because that is exactly what we build. We build tools and products to allow organizations to tie their applications together, to get them to interact and communicate reliably, securely, and observably from the entry point of your application architecture. So if you look at the slide off to the left, people start to go down this path of improving their processes like CI/CD, automation, and go into microservice style architectures. And they need to take that first step in this application networking infrastructure. And that's where we built Gloo. Gloo is our edge gateway or API gateway for getting traffic into a microservices style environment, whether that's running in Kubernetes, which Gloo runs very natively in Kubernetes, or outside of Kubernetes, to be able to route to existing services in Kubernetes or those defined in other registries like Consul or AWS Lambdas and so forth. Right. So that's kind of the first step. You're going down the path of a microservices environment, and you need to start solving these challenges around getting traffic in, controlling it, routing it, doing canary releases, starting to get rich telemetry about the traffic coming in to your architecture, and to secure it, most importantly. Right? And how we secure things at the edge is slightly different than, as we start to go down this path, the services talking to each other, directly. And that's where at Solo, we're big believers in the service mesh pattern or service mesh approach. And so we're building solutions around that, including things like service mesh production support or developer portals for service mesh, sort of fill the gaps where our customers, start to try to operationalize this type of infrastructure. we come in and help and bring expertise, as well as the reality of running these types of frameworks like a service mesh across multiple clusters. And so we built a product called Service Mesh Hub that allows you to simplify those operations. And then lastly, getting this type of technology into a brownfield environment, which our customers are typically, leaders in banking and retail and insurance and so forth. There's a lot of need for fitting backward compatibility, let's say, whether that's some things the applications have been built to do, and they need to stay backward compatible with each other, even though you introduce new services and new applications. Things like security, there might be non-standard security protocols that get used. So that last mile customization at Solo, what we've been very excited about and contributing to and leading in the communities is the emergence of WebAssembly, and specifically WebAssembly coming to this type of API infrastructure, namely Envoy proxy. So, tying all this stuff together, we see Envoy as a sort of foundational piece that enables a lot of the application networking functionality that we need, with the extensibility of Envoy, and then, or of WASM, WebAssembly, and then the ability to manage this across a hybrid footprint, whether that's in Kubernetes, outside of Kubernetes, between clouds, on premises, and kind of helping you treat these as one set of federated networking resources that you can build automation on top of and so forth. So in this particular webinar, so that's what we're doing at Solo. That's why I was excited and still very excited about being here. The part that we're going to talk about in this webinar is the edge and getting traffic into your clusters and managing the security around it. And then what happens when you start to deploy these into multiple clusters or multiple clouds, right? One of the challenges of managing APIs and things like rate limiting and things like service discovery and so forth is in the past, right? This isn't exactly a new problem, but in the past we solved it in environments that were much more static, right? We solved this in large enterprises by doing things like introducing message brokers, right? And let's force everything through the message brokers, and we'll try to apply policies at the message broker level. That evolved into, well, let's connect other things besides just messaging applications. Let's connect services, and so we came up with this enterprise service bus, right? It forced everything through this bus, and we can apply security and observability and location transparency and this type of stuff, right? We can do transformations. And that evolved later then into API management, which we ended up doing the same thing, just centered around HTTP protocols. We'll jam this thing right in the middle and force all the traffic through that and put all our security policies on that and so forth. What we're seeing is in these non-static or more dynamic environments, let's say Kubernetes, for example, that these large centralized bottleneck pieces of infrastructure don't fit that model as well. Services can be scaled elastically. Services can have their IP addresses coming and going, and services can be up, but they're actually unhealthy, right? And so dealing with the uncertainty of the application topology, that exacerbated by the uncertainty of the network in general, makes it much more difficult to do this in a highly centralized environment. So with our modernization efforts and with the technology that we need to solve some of these similar problems around managing APIs, we look toward decentralizing that model. And that's where something like Gloo API Gateway comes into the picture. And so Gloo is built on Envoy. It is built to be a decentralized enforcement point at the edge, and has its API built to reflect that, right? So there's a lot of opportunities for delegation in the Gloo API for describing, various security and rate limiting and transformation properties, routing and so forth around your APIs, and delegation and decentralization of the API so that individual service teams can own the pieces that they care about, right? You don't have to funnel and force everything through a centralized team to make a change to your routing in your API, for example. And so Envoy forms the core on top of Gloo, or Envoy forms the core. We have a control plane provided by Gloo that obviously configures Envoy and enables additional security properties like OIDC or OAuth 2 flows, things like web application firewalling, rate limiting, and things like extending the model, extending with either security plugins or WebAssembly once that becomes better supported upstream, although we do have that available in our alpha and beta releases of Gloo. And run natively in Kubernetes. So run on custom resources. There's no extra databases that you have to run. It's basically a control loop that provides API gateway-like functionality inside of Kubernetes. So keep it super lightweight, easy to deploy. You can deploy it as the ingress to Kubernetes. You can deploy it as a gateway within tenancy that you might see in Kubernetes. So that means in different namespaces. You can run it outside of Kubernetes and attach it to the HashiCorp stack and so forth. So a lot of flexibility, very powerful, and built on a core that was, first of all, made for this type of a dynamic environment, as well as where all the innovation in this space is happening. So Envoy is that foundational piece. So now, when we start to realistically deploy and our customers see this, we'd want to deploy highly decentralized. We want to deploy for some of the constraints that they have in their environments, things like compliance. You can only run certain applications in certain zones, and things like high availability, isolation in terms of both team and process isolation so that you can improve their velocity to make changes and so forth, as well as things like noisy neighbor isolation, right? You don't, and fault domain isolation. You don't want one particular component in a distributed architecture to go down and cause a ripple effect, right? And a cascading effect. There's all of these other reasons, that data locality and cost, especially when you start moving to public clouds, moving data in and out of different zones costs a lot of money, and so forth. So, this decentralized model, which forces our organization, forces the architecture to be a certain way, that the API, the ability to manage these APIs, has to fit this model. And at Solo, that is core to the way we look at this problem, is decentralization for the enforcement points, but you can't get away completely, right, from some level of centralization. And so the model that we prefer is that of loose federation, right? So you have these enforcement points deployed out into the various clusters or infrastructures, and they're focused on providing the security boundaries around that particular cluster or deployment, but they should loosely act as one across the entire landscape. And so that's where the federation capabilities start to come in, and that is what we are going to talk about today and demo for you with Gloo Federation. So specifically, what that means is, and so we announced this a few weeks ago. But specifically what that means is, how do we get a consistent and unified management plane or management automation where we have these distributed data planes or distributed API components running out in our infrastructure to solve things like, first of all, starting at level 0 is configuration. How do we unify the configuration for these different components? How can we write configuration in such a way that is aware that there are multiple of these API gateways out there? The second thing is understanding and discovering what these different API gateways are doing, and in what environments, what do those environments look like? What services are there? Gloo has a very powerful capability around things like service discovery. So we can discover the services that are running in those different environments, all the way down to the level of the API endpoint. Right? So if we find a service running in Kubernetes, we can also do another level and say, oh, this is a gRPC service, and this gRPC service exposes these different functions, or this is an open API spec service, right? So we can get very deep introspection about the capabilities of the services in a particular environment. Now, at the management plane level, that's really interesting stuff to know. Right? So if you know that service A is deployed in cluster 1 and 5, you can do interesting things like if traffic comes into cluster 1 and it's intended to be routed to that service, and that service actually goes down or is misbehaving momentarily, or whatever it is, then the gateway on cluster 1 can automatically reroute the traffic to the other known location where that service exists, cluster 5 in this example, right? So getting the lay of the landscape, understanding what services are running where, what are their health, what are the gateway health properties, and making intelligent decisions about routing in those types of environments is incredibly powerful, and it allows you to simplify your architectures, right? In the past, you might use F5s or other expensive multi-layer ingress technology to solve this. But now if you make the gateways smart enough and the management plane enables that, then you can simplify your ingress architecture. And there's other examples of this, right? Routing based on locality, routing based on data preferences, routing based on shifting the traffic between multiple clusters, multiple zones, or multiple regions, and so forth. So this management plane gives a lot of powerful capabilities that layer on top of this this distributed architecture. So in Gloo Federation, what that looks like is, as I just described, a management plane that runs separately from where the actual API gateways are running. And those API gateways can be running across multiple clusters and multiple different zones independently, right? So it's another part of this decentralization, that if a particular API gateway goes down, that you have some level of failover and high availability, but it doesn't take everything down. And the opposite is true, right? So if that management plane goes down, of course, you do want to deploy for HA with active passive type deployments and so forth. But if the management plane goes down completely, then the individual gateways should be autonomous enough to continue to run, right? So it's a highly resilient architecture. The clients, they're talking directly to the gateway in their individual zones, and that can be specified by geo routing at a higher level, at the L3 level. But then the gateways become smart enough and enabled by the management plane here. And so that's what we'll show you in some of the demos that we got. So here's an example of making those edge gateways smart enough to do things like priority routing or failover. Right? So traffic comes in to a particular gateway, and it's intended for a service foo in this case. And turns out, the traffic landed there and foo's not available. Maybe foo's not healthy, or is returning, misconfigured or whatever it is. And so the gateway then is able to be smart enough and say, okay, well, I know that foo lives over here in cluster whatever, right? In this diagram, it's cluster 2, but I know that it exists somewhere else, and I can just route the traffic directly to where I know there's another foo service. And the Gloo API gateways here, like I said, that routing config and that smarts about, okay, well, I know where this service is and that service is, isn't because the gateways are talking to each other, right? It's because the Federation plane is discovering and updating and keeping up to date a consistent meta model about what is deployed where, and feeding that information into the various gateways. So at this point, let's transition to Joe, and he'll give us a demo of everything that I just said, or some of the stuff that I just said.
Yeah, absolutely. Thanks, Christian. Yeah, so today I'm going to walk you through an example of setting up your Gloo Fed environment for the first time and applying your first failover resource across clusters. So as you can see here on my kind local cluster, I'm running the Gloo Fed console, and which is our read-only UI, as well as the Gloo Fed controller, alongside an instance of Gloo itself. This is not a requirement, but just for convenience for this demo, we're running Gloo Fed and Gloo itself in the same cluster. You'll also see here that I have this echo service deployed. And this is a simple service that just returns Gloo pod when it's accessed. And on my remote cluster, I am running another instance of Gloo and another echo service. This one simply returns green pod to differentiate itself from the original. Great, so the first thing you're gonna wanna do after you've installed Gloo Fed is register your clusters. That can be done simply with GlueCTL. Here I'm going to register the local cluster as well as the remote cluster, the blue and the green clusters, if you will. And what this process does is create a service account, cluster role, and cluster role binding on the remote or registered cluster that contains the minimum required permissions for the Gloo Fed controller to observe and manage Gloo configuration on that cluster. Once that's done, we'll see that we're able to observe those Gloo instances. Let's take a look at the Gloo instance that's running on the kind local cluster here. Here you'll see that we've observed quite a lot of information about the Gloo instance. Some simple things, which is used for some implementation details of failover, such as the ingress endpoint that we can divert traffic to in the case of failover, as well as some robust check information, which you might be familiar with if you've used the GlueCTL check command to debug your Gloo instance. This will give you the number of each resource watched by Gloo in your cluster, as well as report any errors or warnings on those CRDs as observed by the Gloo Fed control plan. We also get some additional information like the number of available replicas of the Envoy proxy, as well as like the version of Gloo that is running there. Great, so to get started with the failover portion of this demo, let's take a look at the virtual service that I'm running on my cluster. Here, you'll see it's a very simple virtual service that diverts all traffic to that blue echo service I referred to earlier. I'm port forwarding to my gateway on localhost 8080, and we'll see that I get this blue pod response. However, if I force health checks to fail on that blue echo service, we'll see that I now get a 503 because there's no healthy upstream to handle that request. We can handle this case with the failover scheme CRD. Here, we see that the failover scheme specifies the primary upstream that it operates on, specifying alternative upstreams to fail back to should health checks fail. This API is robust to support an ordered list of clusters and upstreams within those clusters, to which we should fall back to enable load balancing on the event of a failover. But in this case, we simply fail over to that default green service in the remote cluster that we saw earlier. So now once I apply that failover, we can take a look at it in the cluster, see that it's been accepted by the Gloo Fed controller. And now when we try to make a request to our gateway, we see this green pod response, indicating that traffic reached the remote green pod service. As you scale up your Gloo deployments within your organization, you might find that you're running many Gloo instances and many services with many upstreams available. To make it easier for you to observe your Gloo configuration across clusters, we have delivered the Gloo Fed read-only console. This console is capable of showing you the status of all of your Gloo deployments, as well as keeping you up to date on the clusters that are registered to your system, the virtual services that are available there, and the upstreams across your whole environment. Here we can get some additional detailed information, a visualization of that Gloo instance CRD we took a look at earlier. And we can dive a bit deeper to see the virtual service that we had configured, as well as, in the event of an upstream with failover, the entirety of that failover scheme and the order in which we will fail over to remote upstreams should something go wrong. And that concludes my demo for now. If you're interested in digging deeper, I welcome you to check out the Gloo docs, particularly the guide section under Gloo Federation, to learn more about the failover feature, as well as our federated configuration, multi-cluster RBAC, and other features as they're added to Gloo Fed.
Very nice. Thank you, Joe, for that demo. Let's go back here and wrap up. You should be able to see my screen. And right, so the Gloo Federation capability fits very neatly and nicely with the capabilities of Gloo. And so Gloo is a open source project, first of all, with enterprise capabilities that are open core, right? So what we showed you, the Federation capabilities are part of the enterprise product, but the Gloo open source project you can see here in this table, you know, that forms the core of how we build the Gloo enterprise, and on top of it, of course, the Gloo Federation capabilities. So things like being able to do canary routing, connecting up TCP services, things like auto discovery, routing to AWS Lambdas or Cloud Functions, transformation. These types of things are all part of the open source project. And if you're looking at a suitable ingress for Kubernetes specifically, then Gloo open source makes a great option. And of course, if you have more security needs and enterprise needs, that's where the enterprise product comes in. We have the developer portal and Gloo Fed and the UIs, and of course all of the security things that we typically see in our enterprise customers, of which some of these are the public facing ones, and we've done case studies for. So if you go to our website or go to our blog, you'll see some of the specific use cases that we've solved, and some of the problems that we've solved with our customers here. So just as Joe mentioned, we encourage you to check out the documentation for Gloo, check out the open source project, join our Slack at slack.solo.io. That gives you access to basically this community and wealth of information around building these types of application networking architectures from both the edge perspective as well as the service mesh perspective and WebAssembly, as I mentioned earlier in the webinar. Just a shameless plug, I guess. I will be doing a talk that covers some of this same material, but from a different perspective, which is the service mesh has been traditionally talked about as east-west managing, right? We manage the traffic for east-west, and the API gateway or the edge has always been, this is the north-south traffic. If you've heard those terms before, that describe the direction of traffic flow in a data center. But as you can see, with something like Gloo and distributed API gateways and Gloo Federation and so forth, the line between what is north and south and what is east and west, that's becoming very blurred, and it should, because there is, the traditional data center is sort of being supplanted by this distributed deploying to the cloud, deploying your data center, multiple data centers, multiple cloud, multiple regions, and potentially multiple clouds and so forth. And you need application infrastructure or application networking infrastructure to fit that model. And so I'm doing a talk for the Microservices Summit put on by Alibaba next week on that topic. And we're going to be doing more webinars on this in this area. The one on the 27th, we will discuss some of the deployment patterns that crop up when we run into this highly decentralized infrastructure. We have another one coming up in September about going back to basics. What is the difference between a service mesh and an API gateway, and how do they fit? And we're going to be doing more of this type of topics. So definitely stay tuned. Definitely come check us out on Slack and visit our open source communities. And with that, let's open it up to questions. And
Yeah.
I don't know, I've been clicking on Q&A. I can't see the Q&A, Betty, so maybe you see them.
Oh, okay. I think it's because you're in the share mode, but there was a question that you answered in the chat, but I think it's good to just share with everyone. We had Jason asking, when you mentioned the ability to enforce compliance, does that mean, even being able to block access to APIs by country, as an example?
Mm-hmm. Yeah. And so compliance covers a whole bunch of stuff. The specific question that you asked about blacklisting or whitelisting certain clients and areas from where they originate. So Gloo does have the web application firewalling capabilities that are built on top of mod security, or it is mod security, right? We've basically taken mod security and put it into Envoy, so that you can enable those WAF and tried and true trusted WAF capabilities in the gateway itself. So that's the answer to that specific question. But in terms of compliance, and data sharing or data restriction and network segmentation and so forth, those will also be drivers for how you end up architecting your system, and that will require this decentralization, and Gloo fits very well in that model.
And a common question that we also get is when we talk about Gloo and some of the other things, technologies that we work with is, is Gloo, can you use Gloo or Service Mesh, or are they replacements for each other or complementary?
Yeah, that is very good. And that's why we're going to do that webinar in September. And we've written a lot of blogs on this topic, but in short, what the Service Mesh does and what the gateway does, even though they may share the same underlying technology, they do play different roles. So for example, Envoy can be used at the edge, and at the edge, you're probably going to solve things like, well, the question that we just had before: how do you control access to the services at the edge, and do that in a way where the traffic coming in is not trusted? And we need to figure out the identity of that user, and determine their trust level, and decide whether we're going to allow that in. But there's other things at the edge, like a big part of API Gateway is to shield how you implement a particular service from how you expose it to your clients. And when you do expose it to your clients, you want it to be very easy to find, easy to start to consume in hopefully a self-service manner, and document and so forth. And so the API Gateway helps to facilitate those use cases, which are slightly different than the use cases in the Service Mesh, which are more about, service A needs to talk to service B. I need to observe it. I need to make sure that it's resilient in the face of failures and so forth, and client-side load balancing and circuit breaking and that kind of thing. And you might use Envoy to solve both of those problems, or at least to build on top of to solve both of those problems. So they are very complementary. They overlap in certain areas by the nature, especially if they're built on the same technology. And you can have one without the other as well.
And then that kind of segues well into, we made this Gloo Federation announcement a few weeks ago, but a few months ago, we also had a refresh to something called Service Mesh Hub, and both work on managing multiple clusters, one in API gateways and one for multiple clusters of service mesh. How would these two work together, if at all?
Yeah, they work well together in terms of, at least right now, Gloo Federation would solve the edge API gateway problem, like you mentioned. Service Mesh Hub does the exact same thing, but for service meshes. All right. Now, as I've been hinting at, the more you decentralize, the more you have these deployment patterns, the notion of north, south, and east, west kind of starts to delude quite a bit and converge. And I predict we will see that with our product, Gloo Fed and Service Mesh Hub as well. That that we're going to be solving some of the problems, and the problems at the edge deployed out across a bunch of different clusters is going to look like a service mesh. And so Service Mesh Hub, which already manages a service mesh, should fit nicely in that with that model as well. So they're very complementary, just like a gateway and a mesh are complementary. And in general, we are going to see a convergence of that both in our product stack, but as well as the ecosystem and the community as well. I think that's well on its way, and we're kind of leading that.
Great. And that looks like that's all the questions we have for today. There was an ask in here regarding the link to the documentation. I'll also send that out in a follow-up email that includes the recording, a copy of the slides, and links to the documentation so that folks can try the tutorials themselves. We got one more. This always happens. The minute I say, like, that's all the questions we have, we get another one. But this question here, in a multi-tenant environment where you have a service being shared across many, can Gloo be configured to allow access of this shared service with only the allowed applications that can access it?
Yes. Okay. So So the question is about, can Gloo provide that level of trust and policy enforcement to a backend service that is shared across multiple tenants? And so that is exactly one of the reasons why we've built things like the OPA extensions, or things like being able to route based on a particular user, or some of the context, do some sort of content-based routing, as well as an extension point for extending the auth model. So if there are some other either existing policy engines that you have in place, or it has to be some kind of custom code for whatever reason, then you can also extend the auth model in Gloo to do that. We have docs on that in the Gloo documentation. I think we have videos and so forth to help with that type of thing. But so Gloo should be able to fit a multi-tenancy scenario like that.
All right. Any more questions? Going once, going twice? If you all have questions after this session, you can always join slack.solo.io. We've got a channel for Gloo as well as Gloo Enterprise, and our engineers, Christian, myself, we're all in there every day, and we can help answer questions, as well as you can get input from others in the community who have been setting up various configurations of Gloo for their applications. So thanks all for joining today. We'll get the recording and the slides out, and we'll see you at the next webinar.
Thanks all.
Bye.